here. All right, 5-3, least common multiple, LCM. We're also going to be doing a lot of, and really what we care about more is this, the least common denominator, because this concept is almost entirely used with fractions. We need least common denominators to do any adding or subtracting of fractions. If I have this for a problem, I can't solve it until I have a common denominator. I need to know what the least common denominator or least common multiple is between these two numbers to solve this. Hint, it's 6. 3, 6 plus 2, 6. And only once you have that common denominator can you actually add or subtract. 3 plus 2 is 5 and 6. Tomorrow, well, we got our quiz. Oh, then some ordering. Never mind. Friday, though, adding and subtracting fractions begins. So it's coming up here in a few days. But 5-6. We're skipping 5-4, by the way. So. But tomorrow we'll do our quiz, 5, 1, 2, 3. Do our new lesson, 5-5, comparing and ordering stuff. Basically, greater than, less than, or equal to. Put them in order from greatest to least, or least to greatest. So that's tomorrow. Okay. Vocab, yes. So, first off, what's a multiple? Let's figure that out. So, multiple officially is the product of a number and any whole number. And usually we've done multiple listings many times over. Like if I say 3 and I say, list me all the multiples of 3, basically I'm saying what's 3 times 1? It's 3. What's 3 times 2? It's 6. What's 3 times 3? It's 9. And this pattern goes forever. But if I say list the multiples of 3, you would say 3, 6, 9, 12, 15, 18, 21, you know, as long as we wanted to go for it there. Or any number. Multiples of 6, 6, 12, 18. Right? That's what a multiple is. So, it's not a factor. But we basically, whatever that number is, we just keep using that number, but just multiply down the line. Times whatever that number is times 1. Whatever the number is times 2, times 3, times 4. Easy enough. Common multiples. And I guess we can put our 2 common multiples. You can probably guess we knew what common factors were, right? So common multiples are multiples shared by 2 or more whole numbers. Oh, I'm sorry. My fault. So common multiples. And again, common multiples can pretty much go till infinity. So just for example, say I said, well, what are the multiples of 2? 2, 4, 6, 8, on and on it goes. And then I say, well, what are the multiples of 3? 3, 6, 9, 12, da 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 da. And I say, okay, well, I'll just build it a little farther there. So what would be the common multiples between 2 and 3? Well, 6 is a multiple for both of them. 12 is a multiple for both of them. The other numbers are not common. 9 is a multiple of 3, 3 times 3, but 9 is not a multiple of 2, right? 2, 4, 6, 8, nope, not 9. So very similar to common factors, you can list out multiples and then circle the common. So this brings us to our main point, the least common multiple. And once again, the least common multiple is the least, or lowest, if you wish. Non-zero, 0 is not, it is, but it doesn't get us anywhere to say 0, so we just are excluding 0, okay? 0 doesn't count. Least non-zero common multiple of 2 or more numbers. And just like the greatest common factor, there's only one greatest common factor. There's plenty of common factors sometimes, but there's only one greatest common factor. And with the multiples, well, truthfully, there's infinite number of multiples because, as we saw, especially in that video, I mean, it can get pretty deep in how numbers, and sooner or later, they're going to intersect themselves. But
The Whopper.
right. But in the end, there's only one least common multiple. So if I go back to 2 and 3, what would be the least common multiple between 2 and 3?
6.
Right. It's the first, the lowest, the first number you hit that is that common multiple. That's your least common. So once you get to the least common multiple, all this stuff, it really doesn't matter anymore. We don't need giant. You want the smallest multiple. You always want the smallest multiple, not some, like 24. I mean, it's not a good one to work with there. So there's two different ways to find them, and that's what we'll explore here. So I guess last thing I'll say, least common for our vocab, and then we'll switch over. The least common denominator is pretty much the least common multiple of the denominators of two or more fractions. So when I say least common multiple, I just write out a whole number like this. What's the least common multiple of all this stuff? We'll figure it out. But least common denominator, flip to the back side, it's more or less the same thing. But all I really need to know is what's the least common multiple between 7 and 11? What's the least common multiple between 5 and 2? The bottom numbers are fractions, the denominators. Hence the term least common denominator. You're just finding the least common multiple of the denominators.
For most of these things, can we just or for the whole numbers, can we just multiply them and get that?
Sometimes. So it depends on the numbers. What about this one here?
Well, not fractions, I mean whole numbers.
Well, this is just basically saying what's the least LCM of 7,
yeah.
14, and 28. Like this, I'm just saying 7, 14, and 28. What about if there's four numbers?
I guess it would be if it was 2 numbers, not if it was 3.
Well,
Wait, no,
48
then
and 12
nine.
would be like 500 something, but the least common multiple
Yeah.
is 48.
Yeah.
12 times 4 and
And then
40.
look at 9, it wouldn't be that either.
Right.
Never mind.
So yeah, it's a good thought.
Close enough.
I mean, it's not bad. What you would get though, multiplying, I mean, you could still get somewhere with that. You could just multiply them, but what you're going to have to do then, if you go that route, is you're going to end up having to simplify, because you could get a common multiple, and you would be correct, but you're going to be, instead of working with fractions with over 48, you're going to be doing fractions over 500 and something. So then think about how big your numerators are going to be, and then you're going to have to simplify it when you're done. And that's not going to be a ton of fun. But could it work? Yeah, it totally could, but you're going to have more work to do to make it work. But it would work. If you really want to simplify stuff, then you can. Okay? So, let's look at number 3. And again, these. So, we're going to cover a couple different ways of how this works. And I'll, again, tell you the pros and cons. So, it says find the least common multiple between 2 and 5. So, one strategy you can use, especially with a number this, it would be really ridiculous to build a tree with these numbers. I mean, what would that look like? So, what you can do, if you want, is just start listing out the multiples of each as long as you need to go. So, multiples of 2, 2, 4, 6, 8, 10, 12, so on and so forth, 5, 10, 15, so on and so forth. But as soon as you hit that first match, the least common multiple between 2 and 5 is 10. It's the first multiple that comes up for both numbers. It's the fifth multiple for 2. It's the second multiple for 5. So that one I get you, but okay. Number 4, or not number 4, number 5. So number 5 says 3, 2, and 8. And one more time, I can just go back. I'm going to do it again this way. just because the numbers are really small at the moment, but 2, 4, 6, 8, 10. So usually I just list the first 5 or so. 3, 6, 9, 12, 15, 8, 16, 24, 32, 40. And one more time, I need to find a match on all 3. So 2, nope, 4, 6. Oh, there's a 6, but no. 8. Oh, there's, oh, no, 8. 10. No. So now I haven't found my match yet because it's got a match on all 3. If I have 3 numbers, then it must match on all 3. And then we're going to have 4 numbers. So guess what? We need to find the match on all 4. So what do I got to do? Well, I got to keep going. 12, 14, 16, 18, 20, 18, 21, 24. Let's try that. So 12. There's a 12. No 12. 14. Nope. 16. Nope. 18. There's an up. No 18. 20. Nope. Okay. Let's do it. Go farther. We're not there yet. Okay. 22. Nope. 24. 24. Oh. I found it. Bada bing, bada boom. The least common multiple between 3, 2, and 8 is 24. That's the first multiple that's a match for all 3 of them. Agreed? Agreed? Okay. Now, let's look at number 7. And we're going to solve this one differently. So there they are. It says the common multiple between 6, 8, and 4. And we're going to shift gears because, you know, this first one, this worked out pretty smooth. It didn't take long to get. But this one, well, it took some time. In addition, I will tell you, there are kids that go this route sometimes. I get this whole page of in the past. I don't know. I'll have to ponder. Jace did this.
That makes a lot of sense.
Who else did this? Elizabeth last year.
Also makes sense.
She did it. Kylie attempted it.
Oh, that also makes
But
sense.
here's one of the problems that happens as you're going through, and especially as you start getting deep down the list here, you're very prone to make a mistake. Like with the 8s, all of a sudden you got 50, 58, and things are just, you're doomed at that point there. If you get any of them wrong, and then they're working into the hundreds now at this point, and it's like, it is. And think about how much time has been spent on this totally pointless expedition. They've undertaken a lot, right? So you can probably imagine when we get to something like this, or this, it's, you know, listing out all the multiples of 4, 7, 8, and 14 is going to probably take a while to find the match of all 4. If only there was a better way. If only there is a better way. Hello, factor trees. So, we're going to try this. So, what we want to do, and our trees are going to be much smaller today because we're going to be working with some smaller numbers, as you see. So, your trees aren't going to get out of control here. But, here's what we do. So, we build the trees just like we have before. All right. So there's that tree. There's that tree. And there's that tree. Agreed?
Yep.
So same thing that we did with greatest common factor. But here's where it changes. At greatest common factor, for greatest common factor, you don't have to write this down if you don't want to. But this is what we had to do. We would write them out this way. I'd look for whatever's uncommon to all of them, 2, and that's it. The greatest common factor is 2, right? That's how I would solve it if I use trees for these. But, least common multiple. Write in exponential form. I'm going to show you what we do with that. So, we don't want to write it out in this expanded form. I want to write it exponentially. So this is still 3 times 2. No dispute here. This is 2 to the 3rd power. And this is 2 squared. Agreed with that?
Yeah.
Okay, so now they're all in exponential form. I'm going to go this way now. Then multiply all the different bases together. However, notice on the 2's, though, I got a 3. So somehow it's going to be 3 times 2, because those are my 2 different bases, right? I got a 3, and then I got a 2, another 2, and I'm getting another 2. But I have 2 different bases, right? The 3 and the 2. So we're not done yet, because 3 times 2 is 6. That's obviously not a multiple of 8, so there's more to it. Multiply all the different bases together. In case of a tie, such as this right here, we got that, and we got that. We got a tie. 2 to the third power, 2 to the second power, and 2 to the first power. In case of a tie, use the number with the greatest exponent. Okay, so with this new rule here, I look at my 2's. Again, the 3 is just 3. There's no issue here. I got 2, 2 squared, and 2 cubed. Which one do I want? Well, my directions say in case of a tie with all these 2, I should take the one that has the greatest exponential power. That would be that guy. 2 to the third is bigger than 2 squared, which is bigger than 2. Agreed? So that's the one I want. So that 2 to the third comes with me to my final answer. And now I multiply out. What's 2 to the third power?
8.
8. And what's 3 times 8?
24.
That's my least common multiple. And you can think about it. 4, 8, 12, 16, 20, 24. 6, 12, 18, 24. 8, 16, 24. So if I would list them all out, I would still get to 24. But in this one, again, you could probably list them and get there without too much stress, but I assure you there's going to be some bigger ones coming here, and that's going to be a bad move long term. So I don't force things upon you, but I will need to see at least a couple trees. But it just, you're going to run in the quiz too. There's a beast of a one on there. It's not, but if you use trees, it won't be a beast at all. No beast. But if you start trying to list out all the multiples, there's one that's well in the hundreds for a final answer, and sitting there starting with 2 to get to wherever your answer is in the hundreds is going to take a really long time to write out that many multiples, right? So I strongly suggest this tree method here. It can solve everything, no matter how big the number is. We can just break it down into my exponential form. No matter how crazy the numbers look, just start building your trees, get it down, and then just combine it, and you're done. Even if you don't want any you don't have to know any multiples. But basically what I'm saying is, what does any of this do for me? Well, pretend this was my problem here, right? And I can't add that. I'd have to rewrite them all with this multiple of 24. That's the number I would want. Right? Now I would have that common denominator or multiple or something. Now I can go ahead and add or subtract. Make sense?
What do you do with the never mind.
Okay. All right. Why don't you guys try number 13? Find the least common multiple between 4, 6, 3, and 9. I'm going to give you another little tidbit of advice here. So, again, it seems a little silly to make such tiny trees, because, there's really not much to it here. There isn't. pretty tiny trees, but then in exponential form, right, so there they all are now in exponential form right here. How many different bases do I have? 2. I got the 2 and the 3. The 2, I got a 2 here and a 2 here. Which one do I want?
Left.
Always the one with the greater, because this is just 2, but that's 2 squared. I always want the one with the bigger. This is the 2 I want right here.
Okay.
And ditto, I got a 3, a 3, and a 3 squared. Which one?
3 squared.
Right, that one, right there.
Okay, I get this.
So there's my solution. What's 2 squared? 4. What's 3 squared? What's 4 times 9? There's my least common multiple, 36.
Use your ear,
Um,
bro.
Now, I want to show you something here very briefly. But these two numbers right here, 3 and 9. And again, I'm finding the least common multiple of these 4 numbers, yes. But if I start listing my multiples of 3 out, 3, 6, 9, 12, 15, 18, 21, 24, 27, so on and so forth. And then if I start listing out my multiples of 9, 9, 18, 27, so on and so forth, notice how every single multiple of 9 is also a multiple of 3.
I wonder why.
So when I see this type of problem and I'm figuring this out, I don't even really need this number, to be honest with you, because any of the multiples of 3 are going to be multiples of 9 for sure. Because 9's a bigger number, right?
So if there's like a whole number, should we just like do it aloud? Because
What?
never mind.
And again, you could do what you, if this isn't making sense for you, then I get it. But I don't really care about 3 because all the multiples of 3, and again, I can keep this going. Eventually, I'm going to get 36. I'm going to get 45. I'm going to get 54. Multiples of 3. These are all multiples of 9, too. So anything that's a multiple of 9 is obviously going to be a multiple of 3, too. Obviously. It has to be. It has to be. So when I'm doing this, I can't do anything here because 4, I mean, if I had 4, 8, and 9, like if I had 4, 8, 4, 8, 3, and 9, like this, well, I wouldn't even really need to figure out 4 because all the multiples of 4, 4, 8, 12, 16, 20, 24, they're also going to be multiples of 8, right? So in a sense, if I had 4, 8, 3, and 9, all I really need to figure out is what's the least common multiple between 8 and 9 because all the multiples of 4 and 3 are going to be multiples of either 8 and 9 as well. They are.
Is 0 a number?
Yeah, it's a whole number.
Okay.
Yeah. So you can do what you want with that info. I mean, if that's confusing you, then just build 4 trees. Yes. Sure. Build 4 trees if that's confusing. Okay. All right, let's look at the back side. We're going to be done pretty soon. You guys will have 15, 20 minutes to do some whatever you need. Cool. I don't know what this describe the pattern thing is about. I don't care. Find the least common denominator. I don't know what this means. Okay. And ditto. Find the least common denominator. I don't care about that. So number 19. Let's just look at that. All right. I got 1/5 and 1/2. And now, of course, the directions have only changed in the sense that it's finding least common denominators because we're dealing with fractions. When we just had these numbers here, those were least common multiples. But they are one and the same. So when I say find the least common denominator of these, what I'm kind of really telling you is find this. Find the least common multiple of 5 and 2. And we just had this problem for our first one. What was the least common multiple? Between
I don't know.
5 and 2.
Oh, yeah. 10.
Yeah. So if I say find the least common denominator is 10. So it's the same thing we've done, just taking the denominators of the fractions. Today, we're not rewriting fractions, okay? We're not rewriting them as equivalent fractions. That's coming up oh so soon. Today, it's just about finding the common denominator, not rewriting all the fractions with that common denominator. We know we'll have to do that soon, but today that's not the objective, okay? So don't worry about making these all equivalent fractions right now. I assure you, you'll have that opportunity soon to do that, okay? So let's just do a couple more and call it a day. Find me the least common denominator for 29. 7 20ths, 13 35ths, 2 14ths. And 31. Last two. Then we're done. Unless this goes terrible.
It will.
Well, then we'll do more.
Oh. Okay, so we gotta make sure it doesn't go terrible.
It shouldn't.
So can we just like make trees for the bottom part?
You sure can.
Oh, that's
You can
not
just
nice.
instantly go right to the trees.
That's not nice.
Use your trees.
Fine, I was trying to do it all mentally because I'm smart like that.
It's going to take a little effort.
No,
Personally, I see it right away.
Which one?
The top one. I haven't looked at the bottom one
No, I thought I saw it right away too. I thought it was 60.
yet. All right, go.
60.
So we're finding these are our last two, Faith. If it goes decently. Again, Eve's suggestion was awesome. Let's just get right to this right now. And that's exactly what I do because, again, it would make no sense to list all these multiples. You know, all the multiples of 35, all the multiples of 14. Are you kidding me? Sometimes I ask you what 6 plus negative 9 is, and it takes you 30 seconds to figure that out. So
It's 17?
there's something like that. Negative 3, but that's all right.
Yeah, my bad.
So I would just get right to the trees. I wouldn't mess around with this any other way. And
Bro.
so build our trees.
Oh. Oh.
Ow.
Ow. Ow.
And when you build trees, you're probably concluding these numbers aren't really that giant at all in the end here. So these, there's really nothing to write in exponential form. I got 1, 7, 1, 5, 1, 7, that's it. But this one is 2 squared times 5. So now it's just a matter of putting all the pieces together. What's the answer?
It's 140.
Yes, it is. Yes, it is. Anybody else get 140? So how many different bases do I have here?
3.
Right, I got a 2, a 5, and a 7.
Take the greater exponent.
Right, the 2, I got a 2 here and a 2 here, so it's actually 2 squared.
Yes.
What's 2 squared?
4.
4 times 5 times 7. What's 4 times 5? 20. And what's 20 times 7? 1. And there's my least common denominator, 140. Solved using factor trees. Wasn't that bad, was it?
No, but
Alright.
I don't like multiplying.
Well, that's a different conversation, but. All right, see what you can do with 31. Again,
It's not nice.
I suggest the trees.
Yeah.
Yeah. Listing out all the multiples of 5 to get to the answer would be a brutal
Listing out
expedition.
all of them of... Oh, wait, never mind. I was
Just trying to think of like 27, 27, what come 54, 81, then what? It's gonna you're gonna have to really think it out here for all the multiples of 27 to get where you want to go to, so
I'm gonna die.
terrible. Alright, so this one's for Faith. If she gets it, we're done.
Faith,
better get it
Fake,
wrong.
fake
Look
lock
at
in.
it.
She doesn't.
I know what I'm doing.
I got another one in the hole.
That one's for Eve because I did the other one.
This is true. Face up.
Can I do it?
No, I've heard from you. You're on the right path. So are you. I haven't heard much from Faith though. That's why if she gets it, then I feel good about all three of you. I just need Faith to bring me one home.
She's being a big bad wolf, but really quiet.
Well, Faith's quieter than you two,
Bro, Eve
In
dressed
math
like
class.
Little Red Riding Hood.
but in real life, she's as loud as any of you are.
I ate my grandma.
Math faith is a different faith. Like it's not real faith.
It's not real.
Math Faith? Oh, right.
Yeah,
Jesus
faith
Christ.
in math class is not the real faith.
No.
Yeah, Math Faith is very quiet, very shy.
Because she doesn't want to get called on.
Right.
I don't like doing math because I'm worried I'm gonna get it wrong and then like everyone.
Well, there's only like 3.5 of us here because Colin's like 50% of the time. He's not here today. Colin's a half a person.
That is on record. You saying
I
that?
said it.
Colin, I hope you hear that.
Well, he's here like 60. He's 3/5 of a person. Right? How's that?
I want you to know.
I'd say like 5/8.
Colin, I want you to know. If
All
you
right,
watch
let's
this
give
video-
Colin 10 seconds to respond. Colin, what do you think?
2.
I think it's 1
I guess Colin's on board with whatever we tell him. Okay. All right. Well,
Say nothing.
I want you to
if
know
you're
Yeah.
short.
you jinxed it because you said like the second day of school.
Colin
Just
agrees.
let's think. I haven't been gone at all yet.
It was the second day of school. I was gone.
Colin.
I
Yeah,
was gone.
he's catching up.
I was
He's
gone
doing
in
what
the
he's
first
doing.
week of school.
Okay. Faith. What?
Just the answer?
Sure.
270.
270. What do you guys think?
I got 135.
135?
I got 272.
270.
Bro,
All right.
what am I on?
So 9 and 2, 3 and 3, right?
Got
So this is 3 squared times 2. 27. 9 and 3, 3 and 3. This one's 3 cubed.
Yeah.
And 5 is just 5. Right?
Yeah.
So I got my different bases, a 3, a 2, and a 5. Well, the 5 is the 2. The 3 I need to the third power. Right?
But it was 27.
Right? So
Oh, I didn't see
27
the 2.
times
Bro,
2
I
times
didn't
5.
see the 2.
Bro.
Obviously, because you're exactly half away, so.
I didn't see the 2.
So what's 5 times 2?
10.
Times 27.
270.
Correct answer, 270.
I didn't see the 2.
Sam ignored the 2 because he didn't think it would matter.
Bro's on a math.
But it did matter. You needed that 2. You should have discarded it. So
He's on
that was your bad, not my bad.
That was my bad.
Questions?
No.
Comments?
By singular column.
Bye, Colin.
Those how we not
You got 10 seconds for comments. 8, 7, 6,
Colin, if
4,
you're not here tomorrow, I'm taking your spot.
3,
Colin,
2,
Colin.
1. Goodbye.